So, just the first tip that I want to explain to you before I start with the uh, statistics portion of it is a basic background about what is machine learning. I think many of you know about it, or most of you know about it. But for people who may not be knowing, just a few slides on what is machine learning and what do we do in order to do solve a problem using machine learning techniques. So learning কথাটা যখনই I mean whenever we talk about learning, right? So that means we are trying to acquire some knowledge. And when we are trying to acquire some knowledge, basically it is based on some past experience, right? So say for example, I am trying to acquire knowledge on statistics, right? So that I can do either from a particular person who knows statistics already, okay, who has the experience of either reading through a lot of statistical texts, I mean texts on statistics, or maybe that person is a practitioner in the area of statistics, right? So person who has got experience, I try to pick up the knowledge from that person. So that is one way. The other way is, in some cases, what we do is uh, from our past experience on a similar kind of an exercise, we try to apply that knowledge and try to solve the problem. Say, for example, when I'm trying to say, for example, in our childhood days, we many a times we try to group certain objects, right? So what we try to do is when we were very young, we try to use the notion of color or shape to group the objects, right? So that case, we are not using the past experience directly, but in some indirect form, we are using the past experience. So that is the other form of learning. So where we are basically not using directly the experience, but we are taking some kind of a cue from the past experience and trying to solve the problem. The third type of learning is where we try and commit errors, rectify those errors, and then learn. So, which is called kind of self learning, right? So, for example, a very common example that we all can kind of relate to is, say, for example, when we were very young and tried to learn how to ride a cycle, right? So, that time, no one could actually impart their experience in a direct form or an indirect form. We tried to ride a bicycle. At the same time, we fail, we fall down to on the ground, try to rectify those failures, and then try to come over it, right? So that way we try to learn. So these three forms of learning are replicated in the I mean, these three forms of human learning are replicated in case of machine learning also, right? How? So the first type where we are using the experience, the past experience directly and try to solve the problem, learning problem, is known as supervised learning. And there are further subdivisions of supervised learning called classification and regression. We are not going to focus on these things because that is not the intent of this session. Then the second form of learning where we are trying to use some past experience, not in a direct way, but in an indirect way to solve the problem. That form of learning is called unsupervised learning. Basically, you are not getting the direct supervision from an expert. You are using an indirect supervision or indirect guidance. So that is called unsupervised learning. Again, it might be of different forms. Like one very popular form is the clustering, where we try to group together different objects. The other type of unsupervised learning is association analysis, where we try to associate the different transactions based on how similar or how dissimilar they are, right? So that is the second major form of learning. And third form, which is inspired by the self-learning of human beings, is called reinforcement learning, right? But we are not going to directly get into all these forms of learning. Just we will understand to the extent which is needed to figure out what kind of statistical background is used in machine learning, right? So broadly, these are the three types: supervised, unsupervised, and reinforcement are the three types of machine learning. Now, if we try to look at the process of learning, in a very layman's term, the way it is organized is we have a data, we have the experience, the past experience that we talked about, we have in the form of a data. Okay, and that data is having certain annotation, or which is more commonly known as labeling, right? And based on the data and based on the label that the data has got, the the learning model trains itself. It is called a model training. Okay. And what do we mean by a model? Model is nothing but a simple algorithm in computer. Okay. When you study machine learning in a more deeper way, or if you have already studied machine learning in a deeper way, you know that there are different algorithms behind the different models that we know, right? Say, for example, in supervised learning, the different popular models are k nearest neighbor, decision tree, the naive bayes. So these all these models have a algorithm in the background. These algorithms ultimately what they do is they train themselves based on the data, the training data, okay, which is nothing but a labeled data or a data having annotations. Just to understand what do we mean by that, say for example, I have data of students, okay, and the student data consists of marks in the different subjects and the grade that the student has received, right? So basically marks in say science, marks in humanities, marks in language, all these are the different marks, and these are called the attributes or features, right? And the grade is the target attribute or the target variable. It is the variable which is going to say that the student belongs to a grade A or a grade B or a grade C, right? So when we get a training data, we have got a set of students, the data for a set of students where the marks of the students are given and the grade of the student is given. Marks of the students are called the predictors or the attributes, the independent attributes, and the grade, that attribute or that variable is called the target variable or the target or the label, right? Now, based on that, what we have to do is the model basically trains itself on a set of data of students. And whenever it is being sent, the data, the test data we call it in the machine learning paradigm. So whenever we get the test data, which has got the values for all the independent variables or the predictors, but it doesn't contain the value of the target variable, what the model does is it predicts the value of the target variable based on the input training data. It has built itself, it has aligned itself to the input training data, and based on that, it now assigns a grade for each of the student records, right? Given the marks for the students, right? So now the thing is, this is the supervised learning where we have the training data as the label data. Now, in a similar way, for unsupervised learning, the purpose is a bit different. The data which is there, we don't have any training data here because we don't have any direct supervision or direct expert guidance, right? So what we try to do is we get a data which we try to simply put into a pattern. Say, for example, in a case of a clustering, what we try to do is given a set of input records, we try to group together the similar records, and the dissimilar records are being put into different groups. So for example, if I have a set of data for say 20 students, right, what we do is we put I mean, if we decide that we want to group into, we want to put the students into 4 groups, what we do is we formulate 4 groups, and each of the groups consists of students having very similar kind of a pattern or very similar to each other. And whenever we talk about students belonging to different groups, it is expected they are kind of dissimilar in some aspect or other, right? So that way we try to group together similar objects together, and dissimilar objects we want to put into different groups. So this is unsupervised learning, and similarly there is reinforcement learning. We are not going to cover that part, right? So this is a basic perspective of supervised and unsupervised learning, which are two different categories of machine learning. Now, just to go through very briefly on the machine learning process. So what we have is basically we have got an input data, okay? And input data in case of supervised learning is basically the training data, right? Which is a label data or the data having annotations, right? So based on that, what we do is we prepare a model. We do we try to do the model preparation. Okay. So what do we do as a part of preparing to model? We have certain pre-processing steps, right? Certain pre-processing steps like we need to understand the data, whether there are quality issues in the data. Say for example, certain cases we see that the data, certain values are missing, right? So that's a problem. When we go for modeling, there might be certain issues. Or in certain cases, we might see that for certain instances, there are abnormal values for certain attributes. Again, that's a big issue because that might lead to a model which is a noise, which is like a biased model, okay, or which has issues, right? So if we use that model, maybe the correct kind of prediction is not going to be generated, right? So those things we have to first eliminate, or those issues we have to first eliminate. So that is the step one. We call that a pre-processing step. Then the next step is a very vital step, which is called the learning. So that means after the data is refined, we use that refined data to make the model aligned with the data. Okay, so that means what? For that particular problem, so models, whenever we talk about any machine learning model, that model is kind of a generic thing, right? We can apply that model to solve any problem, right? It can be a problem related to student grade prediction, or it can also be a problem related to weather forecast. And these are completely different domains, right? Now, if we want to tune the model to that particular domain and to that specific data in that domain related to that problem, so that is the part which is being done as a part of learning, and we call that as a model training. Now, once the model is being trained, the next step is how good the model is actually performing. So we call that performance evaluation. How do we do that? What we generally do is from the data, input data, which is the annotated data, we set aside a small portion of that data to do a reality check. So whenever the model is being trained, we use that trained model, apply it on that particular set aside, data set aside, and we make the predictions. Once the predictions are being made, we try to compare the predicted values with the real values and see how different the predicted values are from the real values. The real values are often called ground truth. Okay, so how different are the predictions from the ground truth? And based on that, what we do is we try to evaluate the performance of the model. So generally we use a very term very commonly, we call the model accuracy, right? So model accuracy means how accurate the model is in terms of making a prediction which is close to the reality, right? So, say for example, we are making some 100 predictions. We have 100 records and we are making 100 predictions. We have the ground truth for those 100 predictions. And we see that 95 of those 100 predictions actually are matching with the ground truth. So what we say? We say that the model is 95% accurate, right? So this accuracy is a very basic measure and basic indicator about how good a model is performing or how good a model has been trained, right? Now we use that measure to see whether it is good enough for applying to the problem. If we see that the accuracy is not good enough, say for example, we are getting an accuracy like 63% or say for example 58%, which means a very low accuracy, right? A lot of cases we are getting the prediction not matching with the real data. That case we have to refine those things, right? So what we do is we try to basically improve. We have certain hyperparameters of the model, certain things we can tweak in the model, or it might also be so that the data has some inherent issue. So we need to make certain refinements, further refinements in the data. By doing all those things and by retraining the model, we again check the performance and see whether it has improved or not. So that cycle continues for some time till we get a decent model performance. Or say for example, if we just go by the accuracy, so decent model accuracy, right? So this is how we try to build a machine. I mean, the whole machine learning process. This is how it is kind of segregated, the different high level steps, right? Now, before doing the, so as we talked about, we have a very important initial step, which is the pre-processing step. So that is the step where we need to do a lot of data exploration, we call it, right? What do we mean by exploration? We have to look at the data and look at the data and figure out whether the data is good enough to start with the model training. So that portion is called data exploration, and that is the part of the step one of machine learning process, right? So what do I do to do that? We have to understand the type of the data, the different nuances of the data, the quality of the data, and if needed, we need to remediate the data. And also another very important step is we need to explore the relationship amongst the data. Okay, why do we need to explore the relationship? The reason why we need to explore the relationship is because, again, when you go through the machine learning models, you will see fundamentally what we try to do is we use the predictors to build the model, and the predictors are the values of the predictors. There are certain things which we need to understand. The first thing is, one of the most important thing is how much critical is that particular predictor to find the value of the target variable, or to find the label value, right? So say for example, if I am trying to predict the grade of a student, and if I take a attribute like roll number, right? It is very I mean, understandable, it is very intuitive that obviously roll number of a student doesn't have any bearing with the grade that the student may obtain, right? So that means these two things, the roll number attribute or predictor, doesn't make any valuable contribution in terms of deciding the value of the label, which is the grade. Again, if we look at a different kind of a problem, say we are trying to do a age prediction of a set of population, right? Now, we have different attributes like the height, the weight, and all those different attributes. Okay. Uh, Now, height and weight, they are kind of very similar. Up to a certain age, it is expected that with height, age is also, sorry, with height, weight is also going to proportionally increase. Or with higher weight, it is expected that the person is going to have a higher height. So kind of they are very similar to each other in terms of predicting the value of the age variable, right? So that case, we may not need both the variables, the weight and the height. We may not need to use both the variables. We can just do with one of them. Okay. Now, to understand whether a particular attribute or a predictor or a feature is important in terms of deciding the value of a label or a target variable, right? Or in terms of understanding whether two attributes are very similar to each other, we need to explore the relationship between the different attributes of the data, right? So there the importance comes in. Again, the examples that I gave you are very trivial. This is extremely understandable and anyone can understand, right? But there might be certain features or attributes which are much more complex, or not so much. It may be from a domain on, I mean, in which we don't have so much of a knowledge in. So that case, we need to use certain statistical measures to figure out whether, I mean, how is the relationship between the attributes. Okay, so that is a very important perspective, right? So for doing all these things, we need to go for certain data exploration techniques, right? And the basic data exploration techniques that we use in machine learning, they come from statistics. They are directly the concepts which are from statistics. Okay, and today, I mean, in this particular session, I'm going to cover three basic things, okay, which are derived from statistics. The first thing is called the measure of central tendency. Okay, central tendency, and the indicators that we generally use are mean, median, and mode. The second thing is, or the second set of measures are called dispersion, the measures of dispersion. That means how dispersed or how spread out the data is. Okay. And the typical measure that we use in machine learning, again, which is coming from statistics, is called standard deviation. And the third one is to understand the data value position. Okay, and this is based on a very common concept in statistics known as quartiles. Okay, we can understand the data value positions from the quartiles. Let me expand each of these concepts now so that you get some idea. Maybe you already know all these terms very well, but just to understand how they are related to machine learning. So the first thing, central tendency. So what do we mean by central tendency? What do we understand by central tendency? That's the first thing we need to understand. So uh, we are all very used to with the concept of uh, average, right? We all know what is an average, right? Now, average basically is the value which is a representative values. It is a typical value for a whole set of observations. Say, for example, when I'm looking at a set of students, right, and we try to kind of figure out the student quality. Say, for example, I want to evaluate or compare a group of students of section A with a group of students belonging to section B. Okay, and I want to make the comparison based on the marks in say discrete mathematics, right? Now how do I make that comparison? Because there are 30 students in each of section A and section B. How do I compare them? So what we typically try to do is we try to come up with a value which is like an average value for the set of students belonging to section A and the set of students belonging to section B. Okay, so what do we do that? In a very common layman's perspective, what we try to do is we do a summation of all the marks of discrete maths of the students belonging to section A, and we see that it is coming as, say, for example, for the 30 students, it is coming as, say, some 1800. Okay, we divide it with 30, so we get a average of 60. So 60 is the average discrete maths marks for section A, and we do the same thing for section B, and we get a marks, average marks, which is 65.2. So what we say, that the average marks or the representative marks for section B is 65.2 and for section A is 60. So if we do a relative comparison of the students of section A and section B, probably the students of section B have done a little better than the students in section A. Or okay, not probably. I mean, from the perspective of central tendency or the average, we can say section B students have done better than section A. Okay, so this is a measure of central tendency where we can use a very typical measure, which is the mean. Okay, and same way we can also adopt other measures like median. What do we mean by median? We arrange the marks of the students, say 30 students, we arrange the marks of 30 students in an ascending or a descending way, and what we do is we take the value of the medium students. Okay, so since 30 divided by 2 is 15, what do? We simply take the value of the 15th student, right? And that 15th student, whatever marks that he or she has obtained, we take as that as the representative value or the measure of central tendency. Okay, maybe what we observe is section B, median value is 62, and section A, the median value is 61.3. Again, section B has performed better, but may not be, the differences may not be, the difference is not so much as uh, when we consider mean as a measure of central tendency, right? So like that, we can also go for mode. What is mode? When we try to do a kind of a frequency distribution, right? What we see is which particular marks has got the highest frequency. That means which marks is being obtained by most number of students. And what we see is most of the students in section A has received a marks which is 58, and most number of students in section B has got a marks which is 67. Again, that gives me a value of central tendency using the mode as the measurement. And again, we can see that there is a lot of disparity between the central tendency value of section B and section A. So all these three measures, mean, median, and mode, helped us to understand the whole set of students, section A and section B students, in a different perspective. And in all the three cases, mean, median, mode, we are getting a representative value, and that representative value we are comparing with each other, right? So that is how we try to do a measure of central tendency. And the three basic measures of central tendency that is being generally used are arithmetic mean, mean, median, mode. Mean is again can be of two types, rather three types: arithmetic mean, geometric mean, and harmonic mean. So mean, median, mode, these are the three fundamental measures of central tendency. Mean again consists of three types of measures: arithmetic mean, geometric mean, and harmonic mean. Generally, what we do, we use the arithmetic mean, which is the most common part. Okay, and arithmetic mean again can be of two types: simple arithmetic mean, where there is no frequency concept. So each of the observations, there is a single value for the observation. We calculate the arithmetic mean. Or there can be a weighted arithmetic mean, where in which case basically there is, for each of the values xi, we have got a frequency. So say for example, the mark 62 is being obtained by 3 students, mark 63 is obtained by 5 students. So like this, we have got a distribution for the marks which represents the xi, and the frequency, which is the number of times that marks is being obtained by the students, or number of students who have obtained that marks, right? So that is the fi, right? So what we do is summation of fi xi, that is the cumulative value, that we divide by summation of fi, right? So that is a weighted arithmetic mean. Same way, the geometric mean, the formula is root over of, or nth root of x1 x2 to xn, the product of x1 x2 to xn. Okay, so what we do is we multiply the different xi's, and then we do a root, the nth root. So if there are 30 students, we do a root 30, right, of those students. Same way, we have a geometric, weighted geometric mean, which is x1 to the power f1, x2 to the power f2. So xi to the power fi, and the root is a summation of fi. Okay, so that is a weighted geometric mean. Same way, we have the harmonic mean. So n divided by summation of 1 by xi. That is the harmonic mean. And same way, we can have the weighted harmonic mean. So, but for all purposes, all general purposes, we either use the simple arithmetic mean or the weighted arithmetic mean. In most cases, in machine learning, we use these two measures only for the mean. And median and mode you have already understood, right? So, median, we take the values in order, in a specific order, either ascending or descending, and take the middlemost value. And for mode, we take the frequency distribution, highest frequency, that observation, that value is being taken as the mode, right? So that is the measures of central tendency. Okay, now comes the second measure, which is the measure of dispersion, how dispersed the value is, right? So for that, what we use is, we simply use a formula which is summation of, okay, summation of xi, so each of the observations, so xi minus x bar. And what is x bar? X bar is the mean whole square, okay, xi minus x bar square divided by n. So if I look at it, divided by n, okay. So now if I look at a specific data set, what we have to do, for each of the observation, we have to calculate the xi minus the x bar, the mean value. So we first need to calculate the mean value. So summation of xi by n, we calculate the mean value. Then for each observation, we calculate the xi minus x bar, and then we do a square of that. Once we have done that, what we do is we divide that by the total number of observations, right? So that is the that is called the variance. This is a variance, and when I do a square root of the variance, what we get is the standard deviation. So this is the variance of a set of observations. And again, just note